Okay, so here we have the velocity as a function of time. Okay, and we want to determine the total distance. And here's the formula for it. We're gonna take the integral from a to b of the absolute value of the velocity function. And why do we need to take the absolute value? Let's pretend, I don't know what this function is going to look like, but let's say that it looks something like this. Okay? What happens is that since velocity, so actually let me just write this down, v and t, these portions that are underneath the t-axis, they need to get reflected upwards. Actually, let me make it a bit more symmetric to take all the distance traveled into account. Otherwise, we would be finding the wrong value of the integral, because these values that dip down below, they would be subtracting from the values up above. So the only way to really bring them up algebraically is through, of course, the absolute values. So in this case, we're going to have the integral from 1 to 4 of the absolute value of 2e to the power of negative t over 2 sine of t. Great. So this is a calculator question. So we can plug this into the calculator to figure out the value. With my graphing calculator, this is what it's going to look like. I'm going to go fn int, and then I'm going to write down this whole function. With my calculator, I have to write the absolute value, which is the function abs, to e to the power of negative x over 2 sine of x, comma, x, which is the variable, comma 1, comma 4. So those are that's the a and that's the b. And if I type that in and I plug it in, I will obtain 1.3744. So the answer is C. That's it.